first order ODEs. ODE, I'll only use two acronyms. ODE is ordinary differential equations. I think all of MIT knows that, whether they've been taking it course or not. So we're talking about first order ODEs. Which in standard form are written, you isolate the derivative of y with respect to x, let's say, on the left-hand side, and on the right-hand side, you write everything else. You can't always do this very well, but for today, I'm going to assume that it has been done and it's doable. So for example, some of the ones that will be considered either today or in the problem set are things like, y prime equals x over y. That's pretty simple. The problem set has y prime equals, let's see, x minus y squared. And it also has y prime equals y minus x squared. There are others too. Now, when you look at this, of course you can solve by separating variables. So this is solvable. This one is, in neither of these can you separate variables, and they look extremely similar, but they are extremely dissimilar. The most dissimilar about them is that this one is easily solvable, and you'll learn, if you don't know already, next Friday, how to solve this one. This one, which looks almost the same, is unsolvable in a certain sense. Namely, there are no elementary functions which you can write down which will give a solution of that differential equation. So right away one confronts the most significant fact that even for the simplest possible differential equations, those which only involve the first derivative, it's possible to write down extremely looking simple guys. I'll put this one up in blue to indicate that it's bad. Whoops, sorry. I mean, not really bad, but recalcitrant. It's not solvable in the ordinary sense in which you think of an equation as solvable. And since those equations are the rule rather than the exception, I'm going to devote this first day to not solving a single differential equation, but indicating to you what you do when you meet a blue equation like that. What do you do with it? So this first day is going to be devoted to geometric ways of looking at differential equations and numerical. At the very end, I'll talk a little bit about numerical.